Have you ever looked up at the night sky and wondered where it all ends? What lies beyond the farthest star we can see? Is there even an end at all? Infinity is not a place. It is not even a direction. It is a question that never stops. If the universe is infinite, then every journey continues. Every pattern repeats. Every possibility exists. And tonight, we do not run from that thought. We float into it. Gently, quietly, wondering what it means to be inside something that never ends. Close your eyes and imagine standing on a vast ocean. The water stretches in every direction. No matter how far you sail, there is always more horizon. This is how we might think of our universe. Not as a sphere with boundaries, but as an endless expanse. When we speak of infinity, we often reach for symbols. The figure 8 on its side, the snake eating its own tail. But these are merely human attempts to cage something that cannot be contained by thought alone. The stars above us tell a story. They whisper of distances so great that light itself grows tired traveling between them. Of time scales so vast that mountains rise and fall like breath. Of spaces so endless that our minds can only glimpse them in fragments. Like trying to understand an ocean by holding a single drop of water. Think of the smallest thing you can imagine. An atom, a quark, the space between thoughts. Now think of the largest, a galaxy, a cluster of galaxies, the observable universe. Infinity contains them all, without effort, without strain. It holds the microscopic and the cosmic in the same gentle palm. Scientists tell us that the observable universe spans nearly 94 billion light-years across. That number alone is beyond true comprehension. But what lies beyond that boundary? Not an edge, not a wall, but simply more. More stars, more galaxies, more space, and time, rolling outward without end. In our daily lives, we are surrounded by limits. Our bodies can only move so fast. Our minds can only hold so much. Our lives extend only so far. Perhaps this is why infinity both terrifies and comforts us. It is the ultimate release from the boundaries that define our existence. What does it mean to be a finite being in an infinite cosmos? Are we insignificant specks, our lives meaningless against the backdrop of forever? Or are we made more precious by our very rarity, our fleeting consciousness, a miracle in the endless void? Tonight, we will not rush to answer these questions. We will let them breathe, let them expand, like the universe itself. For in contemplating infinity, we are not seeking certainty. We are practicing wonder. The ancient philosophers believed that looking up at the night sky was the beginning of wisdom. When we confront infinity, we confront the limits of our understanding. We stand at the edge of knowledge and peer into mystery. There is a certain peace in this, a release from the need to comprehend everything, to categorize and contain. Infinity teaches us humility, but also connection. For if the universe extends without end, then somewhere in that vastness are other worlds, other beings, perhaps even other versions of ourselves, living lives both familiar and strange. As we drift through this meditation on the endless, remember that infinity is not just out there among the stars. It lives in the spaces between atoms, in the branching possibilities of each moment. In the recursive depths of consciousness itself, infinity is not separate from us. We are not merely in an infinite universe. We are of it, made from the same elements that burn in distant suns, governed by the same laws that shape galaxies, connected by threads of causality to the farthest reaches of space and time. What if every thought you have ever had continues to ripple outward, like light from a star? What if every decision branches into infinite possibilities? What if, in some sense we cannot fully grasp, nothing ever truly ends? Let these questions settle around you like a gentle mist. Feel their weight and their weightlessness. There is no rush to resolve them. No need to grasp at answers that will always remain partly beyond our reach. Instead, breathe with the rhythm of an expanding universe. In and out, beginning and becoming, always in motion, yet somehow eternally at rest. As we continue our journey into the concept of infinity, we will explore what science tells us about the shape and extent of our cosmos. we will consider the strange and beautiful consequences of a universe without end. We will contemplate what it means for time, for life, and for our own brief but brilliant existence. But for now, simply be with this thought. This universe that cradles us may have no edge, no limit, no end. And rather than diminishing us, perhaps this endless context is what gives our fleeting moments their deepest meaning. For in an infinite universe, even the smallest life is not lost, the briefest moment not forgotten. Each conscious experience becomes a unique point of light in the endless dark. Not insignificant, but irreplaceable. So look up at the stars tonight, or simply close your eyes and imagine them. Let your mind expand beyond its usual boundaries. Feel yourself as both infinitesimal and infinite. A temporary arrangement of atoms experiencing itself. A universe becoming conscious of its own beauty. This is what it means to be in an infinite universe. Not to be lost, but to be found. Not to be meaningless, but to be part of meaning itself. Not to be alone, but to be connected to everything that is, was, or ever could be. Our journey into infinity begins now, not with certainty, but with wonder. Not with answers, but with better questions. Not with fear of the endless, but with love for it. There is a certain liberation in imagining ourselves as both unique, the pressure of having only one life to live, only one chance to get it right, dissolves into a cosmic generosity where every possibility unfolds somewhere, not as a replacement for this life, but as an affirmation of its limitless potential. In the quiet of night, as your consciousness drifts towards sleep, imagine those other yous scattered across the infinite cosmos, some awake, some dreaming, some yet to be born, some long departed, not separate from you, but variations on the theme that is you, not diminishing your uniqueness, but celebrating it in endless reprise. This is life in an infinite universe, both singular and plural, both precious and abundant, both unique and inevitable. A pattern that repeats across endless space, like stars reflected in still water, like music that echoes forever. This is time in an endless space, a path without end, a journey with infinite destinations, a story that continues forever yet is complete in every chapter, a rhythm that never ceases yet holds stillness in each beat. However the universe ends, if it ends at all, we exist now in the midst of its unfolding. However time flows, fast or slow, forward or in cycles, we experience it as a precious medium in which life and consciousness bloom. In an infinite cosmos, our finite span of awareness becomes not a limitation, but a unique perspective, a particular window onto the eternal. Like a wave on an endless ocean, we rise, move, and dissolve back into the greater whole. But the pattern that is us continues somewhere, somehow, in the infinite permutations of matter and energy across the boundless sea of space and time. This is existence as a moment within eternity. This is stillness in infinite motion. This is what it means to be temporal beings in a universe that may transcend time itself. Applied to the cosmos, this suggests the possibility of different scales of infinity. Perhaps the infinity of possible particle arrangements is smaller than the infinity of space itself, ensuring that patterns eventually repeat, despite infinity's vastness. These mathematical distinctions become physically relevant when we consider information theory. The maximum amount of information that can be stored in a finite volume of space appears to be finite, limited by the Bekenstein bound. This suggests that even in an infinite universe, the possible configurations within any bounded region remain finite, forcing patterns to eventually repeat across infinite space. Another strange consequence involves what physicists call baby universes. Some theories suggest that black holes might give birth to new universes, with each singularity spawning a new cosmic bubble, disconnected from our own. If our infinite universe contains infinitely many black holes, it could be generating infinitely many new universes, each with their own laws of physics. This nested infinity, universes within universes, stretches conceptual boundaries even further. Our cosmos might be not just infinitely large, but infinitely fertile, constantly birthing new realities across an endless tree of creation. The philosopher Nick Bostrom has suggested another unsettling possibility: the simulation argument. If civilizations can create simulated universes containing conscious beings, and if an advanced civilization could create many such simulations, then simulated beings would vastly outnumber non-simulated ones. In an infinite universe, with infinitely many civilizations, the number of simulated realities would utterly dwarf base reality. Statistically, this suggests we are far more likely to be living in a simulation than in a non-simulated universe. This probability approaches certainty in an infinite cosmos with infinitely many technological civilizations. As these examples illustrate, infinity isn't just big, it's weird. It transforms probability, challenges identity, multiplies possibility, and stretches logic to its breaking point. The consequences of an infinite universe go far beyond mere size, touching the deepest questions of existence, consciousness, and reality itself. Perhaps the strangest consequence of infinity is how it affects meaning. In a finite universe, rare events seem significant precisely because they are rare. But in an infinite universe, where everything possible happens infinitely many times, what becomes of significance? Some find this infinity of possibility liberating. If everything that can happen does happen somewhere, perhaps we are freed from the burden of missed opportunities or roads not taken. Somewhere, every possibility is explored. Others find it troubling. If every possible action and its opposite both occur infinitely many times throughout the cosmos, does choice lose its meaning? If every story plays out in every possible way across infinite space, does narrative itself dissolve into white noise? The paradox may be that infinity both empties and fills the concept of meaning. It empties it by making everything common, every rarity infinitely repeated. Yet it fills it by making everything actual, every possibility realized. Meaning shifts from uniqueness to specificity, from only here to right here, in this particular expression of cosmic possibility. As you drift towards sleep, consider that in an infinite universe, this moment of consciousness, this exact configuration of thought and sensation, is both utterly unique in its specific instantiation and infinitely repeated across endless space. You are both singular and plural, alone and accompanied, unique and common. This is the strange poetry of infinity. This is logical thought stretched across endlessness. This is the realm where paradox becomes possibility, where strangeness becomes the natural state of things, where the extraordinary becomes, somehow, ordinary through its infinite repetition. The physicist Richard Feynman expressed this when he said, "I think nature's imagination is so much greater than man's, she's never going to let us relax. Each answer reveals new questions. Each discovery opens new mysteries. The game never ends, and this perpetual opening is itself a kind of beauty." Love of infinity manifests as reverence without worship, appreciation without possession, attention without exhaustion. It is the love expressed by the astronomer who spends nights mapping distant galaxies, the mathematician who explores abstract spaces, the poet who searches for words to capture the uncapturable. This love extends to the finite as well. When we see each moment, each being, each experience as a unique expression of infinite possibility, we can love it for exactly what it is, neither more nor less. The particular gains poignancy through its relationship with the endless. The emotional landscape of infinity includes yet other territories: nostalgia for cosmic origins, anticipation of endless futures, curiosity about what lies beyond every horizon, peace in accepting the limits of our knowledge, and joy in the free play of exploring what we can. No single emotion defines our relationship with the infinite. Rather, we move through a complex emotional ecosystem. each feeling arising from and giving way to others. As our contemplation deepens, different people inhabit different regions of this emotional landscape. Some linger in awe, others in wonder. Some grapple with fear, others rest in peace. Together, these emotional responses form what might be called the felt reality of infinity. Beyond concepts and calculations lies this lived experience, this embodied relationship with that which exceeds all boundaries. Even those who doubt the physical infinity of our universe can enter this emotional territory. The imagination of infinity, the contemplation of possibility without end, opens these feelings to anyone willing to look up at the night sky and wonder. As you rest in the quiet darkness, feel these emotions moving through you like weather through an open landscape. Notice how they arise and pass, how they blend and separate. There is no right or wrong way to feel about infinity. There is only your unique relationship with the endless. This emotional journey is as valuable as the intellectual one. To fully understand what it means to be in an infinite universe, we must engage not just with concepts but with feelings, not just with calculations, but with lived experience. The heart stretched across space feels differently than the heart confined by boundaries. It beats to a rhythm that includes silence as well as sound, absence as well as presence, mystery as well as knowledge. It expands to include what cannot be included, to love what cannot be fully known, to participate in what cannot be fully understood. This is what it feels like to be in an infinite universe, not lost, but found, not diminished, but expanded, not alone, but connected, not merely existing within something endless, but embodying that endlessness in the finite miracle of conscious experience. As night deepens around you, as your awareness shifts towards sleep, hold gently this paradox. You are both infinitesimal and infinite. Your physical form occupies the tiniest fraction of cosmic space, yet your consciousness can encompass the concept of infinity itself. You are both a moment in endless time and a witness to eternity. You are the infinite experiencing itself through the miracle of finite being. This is humility in the infinite. This is the heart stretched across space. This is meaning in the absence of boundaries. This is what it means, in the deepest sense, to be at home in an endless cosmos. Have you ever tried to imagine something that goes on forever? Not just very big, but truly without end. When we look at the night sky, we see stars stretching into darkness. Our telescopes reveal galaxies upon galaxies, each containing billions of stars. But is there a point where it all stops? A cosmic wall marking the edge of everything? Or does space continue endlessly in all directions? This is the question of infinity. And it changes everything about how we understand our place in existence. First, we must understand what infinity truly means. Infinity is not simply a very large number. It is not a billion stars, or a trillion galaxies. Those numbers, however vast, are still finite. They can be counted, at least in principle. Infinity is fundamentally different. It means without bound, without limit, without end. An infinite universe would not just be bigger than we can imagine. It would be bigger than any size we could ever specify, no matter how enormous. Consider the difference between a very large circle and an infinite plane. The circle, no matter how gigantic, has boundaries. It has a center and an edge. But an infinite plane has no edge. No matter how far you travel in any direction, there is always more. There is no center to an infinite plane, because every point is surrounded by infinite space in all directions. This brings us to a profound insight about an infinite universe. In such a cosmos, Earth is not at the center, but neither is any other planet, star, or galaxy. In an infinite universe, everywhere is the middle of everywhere. Every point is surrounded by infinite space. Scientists often discuss different models of infinity when describing the universe. One distinction is between a finite but unbounded universe and a truly infinite one. A finite but unbounded universe is like the surface of a sphere. If you travel in one direction long enough, you would eventually return to your starting point, just as a ship sailing around Earth would. The space has no edge or boundary, yet it contains a finite volume. A truly infinite universe, by contrast, extends forever in all directions. No matter how far you travel, you will never return to where you started simply by moving in a straight line. There is always more space, more galaxies, more stars ahead. How can we tell which kind of universe we inhabit? Scientists look at the geometry or shape of space itself. Just as a sheet of paper can be flat or curved, space can have different shapes. The curvature of space is related to its density. If the universe contains enough matter and energy, space curves back on itself, creating a finite but unbounded cosmos. If the density is below a critical threshold, space remains flat or even curves outward, potentially extending infinitely. Current observations of the cosmic microwave background, the oldest light in the universe, suggest that space is remarkably flat, at least as far as we can measure. This flatness hints at the possibility of an infinite universe, though it does not prove it conclusively. In an infinite universe, there is no special place, no privileged location, no center from which everything began. The Big Bang, in this view, did not happen at a particular point in space. It happened everywhere at once, in a space that was already infinite, but infinitely dense. As the universe expanded, it did not grow into existing space. Space itself stretched, carrying galaxies apart, like dots on an inflating balloon. But if the universe was already infinite before expansion began, then it remains infinite now, just less dense. This absence of boundaries gives infinity a strange kind of freedom. In a finite universe, we could in principle map everything that exists. We could count every galaxy, catalogue every star. But in an infinite universe, no matter how much we discover, there is always infinitely more beyond our reach. Think of what this means. No matter how far our telescopes peer into space, they will never see everything. No matter how long civilization exists, it could never explore more than a finite region of an infinite cosmos. There will always be new frontiers, new mysteries, new discoveries, waiting beyond the horizon. Infinity also introduces a profound symmetry to existence. In all directions, as far as we can see, the universe looks roughly the same. Galaxies are distributed in similar patterns. The laws of physics appear consistent. This cosmological principle, as scientists call it, aligns naturally with the concept of an infinite universe, where no region is special or unique. Yet infinity also introduces paradoxes. If the universe extends infinitely in space and contains a finite number of possible arrangements of matter, then given enough distance, patterns must eventually repeat. This leads to the unsettling possibility that somewhere, unimaginably far away, there could be exact copies of our Earth, our solar system, even ourselves. This is not mysticism or science fiction. It is a mathematical consequence of infinity. In an infinite universe with finite possible states, even the rarest configurations must occur not just once, but infinitely many times. When we contemplate an infinite universe, we are forced to reconsider our intuitions about uniqueness, about possibility, about existence itself. The line between the actual and the possible begins to blur. In an infinite cosmos, anything that can happen, does happen, somewhere. The history of our understanding of cosmic scale is a story of continuous expansion. With each new telescope, each new method of observation, we have discovered that the universe is larger than we previously thought. From a geocentric model where Earth stood at the center of creation, we moved to a heliocentric model with the Sun at the center. Then we realized our Sun is merely one of billions of stars in the Milky Way galaxy. Then came the revelation that the Milky Way is just one among billions of galaxies in the observable universe. Could infinity be the next step in this progression? Just as the universe proved larger than our ancestors could imagine, perhaps it is larger even than we can imagine, extending beyond any limit we might impose. Consider the night sky. The darkness between stars is not empty. It is filled with light too faint for our eyes to see, from galaxies too distant to discern. If the universe were infinite and eternally old, then every line of sight would eventually intersect with a star, and the night sky would blaze with light. This paradox, known as Olbers' paradox, troubled astronomers for centuries. The resolution came with our understanding that the universe has a finite age. Light from the most distant regions has not had time to reach us. The cosmic horizon, the limit of what we can observe, is determined not by the edge of the universe, but by the age of the universe. The darkness of night is evidence, not of cosmic boundaries, but of cosmic youth. Yet beyond that horizon, space may continue. Galaxies we will never see may shine in an eternal dance. Stars may burn and die, and be reborn in patterns mirroring our own visible cosmos. In an infinite universe, everything we can observe is merely a bubble in an endless sea. The concept of infinity stretches not just our imagination, but our language. We speak of distances in light years, a unit already beyond human scale. A light year is the distance light travels in a year, nearly 6 trillion miles, or about 9.5 trillion kilometers. Our galaxy spans about 100,000 light years. The observable universe extends about 46 billion light years in every direction. But infinity makes even these numbers seem small. If the universe is infinite, then for any number of light years you name, the universe extends farther still. No number can capture its extent. No journey could reach its end. This limitlessness has philosophical implications as well. In Western thought, infinity was often associated with the divine, the only context in which true limitlessness seemed conceivable. Eastern philosophies embraced cosmic cycles of infinite duration. Modern physics approaches infinity with mathematical precision, yet still finds it challenging to conceptualize. An infinite universe would be, in a sense, complete. It would contain all possibilities, all variations, all potential histories and futures. Yet paradoxically, it would also be perpetually incomplete from the perspective of any observer. No matter how much we discover, infinitely more would remain unknown. As you rest beneath the stars tonight, consider that the space above you may have no end. The cosmos may stretch beyond any boundary we could imagine, filled with worlds and wonders we will never see. This is not a thought to make us feel small or insignificant. Rather, it connects us to something boundless. In an infinite universe, each finite moment, each individual life, is not diminished, but rather made more precious by its unique place in the endless tapestry of existence. Infinity is not just the absence of limits, it is the presence of endless possibility. It is the shape of forever, the freedom of having no boundary, the wonder of being part of something that never ends. How can we possibly measure something without boundaries? What evidence do we have that our universe might extend forever? These questions take us to the frontier of cosmology, where observation meets theory in our quest to understand the true nature of reality. Our journey begins with what we can actually see. When we look up at the night sky, we are looking back in time. Light from distant stars and galaxies has traveled across vast distances to reach our eyes. The farther away an object is, the older the light, giving us a window into the cosmic past. But there is a limit to what we can observe. Since the universe has a finite age, approximately 13.8 billion years, we can only see objects whose light has had time to reach us since the beginning of the universe. This creates what astronomers call the observable universe, the spherical region around us, from which light has had enough time to arrive at Earth. The radius of this observable bubble is not 13.8 billion light-years, as one might initially think. This is because space itself has been expanding while the light travels towards us. When we calculate this expansion, we find that the most distant objects we can theoretically observe are actually about 46.5 billion light-years away in every direction. Beyond this cosmic horizon lies space we cannot see, not because it is not there, but because its light has not had time to reach us. It is as if we are standing in a dark field with a lantern that illuminates only a small circle around us. We cannot see beyond the reach of our light, but we can infer what might lie in the darkness. So how do we make these inferences? How do we gather evidence about the shape and size of a universe we can only partially observe? The most powerful clue comes from measuring the geometry of space itself. Just as the surface of Earth can be flat on small scales but curved on large scales, the fabric of the universe has a shape. This shape is intimately connected to the question of whether the universe is finite or infinite. There are three possible geometries for our universe: closed, open, or flat. A closed universe curves back on itself like the surface of a sphere. It has positive curvature and contains a finite volume. An open universe curves outward like a saddle and extends infinitely. A flat universe has no curvature at all and also extends infinitely in all directions. To determine which of these geometries describes our universe, cosmologists look to the oldest light we can detect, the cosmic microwave background radiation, or CMB. This faint glow, discovered in 1965, is the afterglow of the Big Bang itself, released when the universe was just 380,000 years old. The CMB acts like a cosmic fossil, preserving information about the early universe. By analyzing patterns in this radiation, scientists can measure the geometry of space with remarkable precision. What they have found is extraordinary. As far as we can tell, the universe is flat to within a margin of error of less than 1%. This flatness suggests that our universe might indeed be infinite. In a flat universe that extends forever, parallel lines never meet, and the interior angles of a triangle always sum to exactly 180 degrees, even on cosmic scales. While our observations cannot prove infinity, they are consistent with an infinite cosmos. The flatness of space presents its own puzzle. In the early universe, the density of matter and energy needed to be exquisitely balanced to produce the flat geometry we observe today. Any slight deviation would have caused the universe to either collapse in on itself or expand so rapidly that galaxies could never form. This knife-edge balance is known as the flatness problem. To address this and other cosmological puzzles, physicists developed the theory of cosmic inflation. According to this theory, the very early universe underwent a brief but incredible period of exponential expansion, doubling in size many times in a fraction of a second. This inflation would have stretched space so dramatically that any initial curvature would have been flattened out, just as the surface of a balloon appears flatter as the balloon expands. Inflation not only explains the observed flatness of our universe, but it also suggests that what we can see might be just a tiny fraction of what exists. Some versions of inflation theory propose that inflation never completely stops, creating an eternally inflating multiverse containing countless bubble universes, each with its own laws of physics. While these ideas venture into speculative territory, they demonstrate how observations of our observable universe can lead to inferences about what might lie beyond. Another line of evidence comes from the overall distribution of galaxies in space. The cosmological principle, a foundational assumption in modern cosmology, states that on large scales, the universe is both homogeneous and isotropic. This means that matter is distributed roughly evenly throughout space, and the universe looks approximately the same in all directions. Surveys of galaxy distributions confirm this principle. While galaxies cluster together on smaller scales, forming filaments and superclusters, on scales larger than about 300 million light-years, the distribution becomes remarkably uniform. This uniformity is exactly what we would expect in an infinite universe, where no region is special or central. The uniform expansion of the universe provides additional evidence. Observations show that galaxies are moving away from us in all directions, with more distant galaxies receding faster, following a pattern known as Hubble's law. Crucially, this expansion looks the same from any vantage point in the cosmos. An observer in a distant galaxy would see the same pattern of recession that we do, just as we would expect in an infinite universe with no center. Every new telescope, every enhanced measurement, every refined observation has only expanded our understanding of cosmic scale. The James Webb Space Telescope, the most powerful space observatory ever built, is peering deeper into space than ever before, revealing galaxies from the dawn of cosmic time. Yet even this remarkable instrument can only see a fraction of what may exist. In this quest to understand cosmic scale, we continually push against the boundaries of what we can observe. But no matter how advanced our instruments become, our cosmic horizon will always be limited by the finite age of the universe. We can never observe an infinite cosmos in its entirety. Every new discovery expands the known, but leaves the unknown wider still. This limitation creates a profound humility in cosmology. The edge of what we know is not the edge of what is. Our maps of the cosmos will always be incomplete, like ancient maps of Earth, with vast regions labeled, "Here be dragons." Infinity begins where certainty ends. Consider the implication of these observations. Our best measurements suggest a flat universe, consistent with an infinite cosmos. Our observations of uniformity and isotropy align with what an infinite universe would look like. The most elegant and comprehensive theories of cosmic evolution point toward a universe far larger than what we can see. And yet, we cannot prove infinity. We can only infer it. We are like explorers on an endless ocean who have charted a small bay. We cannot see across the entire ocean, but we can test the water, measure the currents, study the patterns, and make educated guesses about what lies beyond the horizon. This uncertain knowledge creates a unique kind of wonder. Each discovery that pushes back the boundaries of the known universe leaves more room for the unknown universe beyond. Like a fractal pattern that reveals new complexity at every scale, our cosmic understanding expands but never completes. The mathematician Georg Cantor, who revolutionized our understanding of infinity, once wrote that the essence of mathematics lies in its freedom. Perhaps the same can be said of cosmology. In confronting the possibility of an infinite universe, we free ourselves from the confines of limited thinking. We open our minds to possibilities beyond what we can directly observe or intuitively grasp. As you contemplate these ideas, imagine yourself not as a static observer, but as a participant in an ongoing cosmic journey. Every observation we make, every measurement we take, every theory we develop brings us one step closer to understanding our place in this possibly infinite cosmos. The universe might be infinite, or it might not be. The evidence points tentatively toward infinity, but uncertainty remains. And perhaps that uncertainty is appropriate when contemplating something as vast as the cosmos. For in the space between what we know and what we wonder lies the true adventure of scientific exploration. Tonight, as you rest beneath the stars, remember that those distant points of light are messengers from the edge of our visible universe. Beyond them may lie galaxies unseen, stars uncharted, worlds unimagined, stretching onward without end. Infinity begins where certainty ends, and it is in that boundary space that our most profound cosmic questions continue to unfold. What does it mean for us, for life itself, if we truly inhabit an infinite cosmos? How does the possibility of endless space transform our understanding of existence? These questions take us beyond physics into the realm of profound possibility. Imagine standing on a beach, watching waves roll endlessly toward shore. Each wave is unique in its exact shape, in the pattern of foam it creates, in the precise sound it makes as it breaks. Yet the process of waves is also endlessly repetitive, governed by the same physical laws, creating patterns that echo one another without ever precisely repeating. Now expand this vision to the cosmic scale. In an infinite universe with a finite number of ways to arrange particles, matter must eventually, after unimaginable distances, begin to repeat its configurations. This is not mysticism or speculation, but a mathematical certainty that emerges from infinity itself. Consider the building blocks of our physical reality. There are only so many types of fundamental particles in existence. These particles can only arrange themselves in a finite number of ways within any bounded region of space. The number is astronomically large, but crucially, it is not infinite. If the universe is truly infinite, but the number of possible particle arrangements within any finite volume is finite, then patterns must eventually repeat. The mathematician Roger Penrose compares this to a chess game. While the number of possible chess games is enormous, it is not infinite. If chess were played eternally, games would eventually repeat. What does this mean for us? Something remarkable. In an infinite universe, given enough distance, there must exist exact replicas of Earth. Planets identical to ours, in every measurable way. And on these planets, there must exist people indistinguishable from us at a physical level. The distances involved are beyond comprehension. To find an exact duplicate of our observable universe, we would need to travel roughly 10 to the power of 10 to the power of 120 light-years. This number is so large that it cannot be written out in conventional notation. It dwarfs even astronomical quantities like the number of atoms in the observable universe, which is a mere 10 to the power of 80. Yet in an infinite universe, even this incomprehensible distance is just the beginning. Beyond that first duplicate would lie endless others, stretching into infinity. These duplicate regions would contain duplicate Earths with duplicate histories. Some would be identical to our world in every detail. Others would differ in small ways, a different outcome to a coin toss, a different choice at a pivotal moment, a storm that never happened, or a chance meeting that did. If true, this means that somewhere, unimaginably distant, another you is listening to these same words right now. And another you made a slightly different choice this morning. And another, you was never born, because history unfolded differently. Every possibility that can exist does exist, somewhere in the infinite cosmos. This concept, sometimes called the multiverse by infinity, differs from other multiverse theories that arise from quantum mechanics or string theory. Those theories propose parallel universes in other dimensions or branching timelines. The infinite spatial multiverse simply suggests that if you travel far enough in our own universe, you will find every possible variation of reality. The philosopher Friedrich Nietzsche anticipated this idea in his concept of eternal recurrence, the notion that given infinite time, events must repeat themselves. In an infinite universe, recurrence happens not just across time, but across space as well. How does this change our understanding of identity? If there are infinite versions of you scattered throughout the cosmos, are they all truly you? Or are they different people who share your exact physical structure? The question challenges our intuitive sense of uniqueness and selfhood. Some find this concept disturbing, a threat to individual identity. Yet others find deep comfort in cosmic mirrors. The poet Walt Whitman wrote, "I contain multitudes, embracing the multiplicity within himself." Perhaps there is similar beauty in embracing the multiplicity of ourselves across an infinite cosmos. The infinite universe presents another profound implication for life. If space is endless and the laws of physics remain consistent throughout, then life itself is not a rare accident, but an inevitable phenomenon, repeated countless times. The emergence of life on Earth required a precise set of conditions: a planet at the right distance from its star, water in liquid form, a mixture of essential elements, protection from cosmic radiation, stability over billions of years to allow evolution to unfold. In a finite universe, we might wonder if these conditions are rare, making Earth special, perhaps even unique. But in an infinite universe, every possible configuration of matter exists somewhere. Planets with conditions identical to Earth must exist in unlimited numbers, and so must planets with conditions similar but not identical to ours, some perhaps even more conducive to life. This means that life, far from being a cosmic accident or miracle, becomes a mathematical inevitability. In an infinite cosmos, life would emerge not just once, but infinitely many times, in infinitely varied forms. Astrobiologists studying the possibility of extraterrestrial life often focus on the concept of the habitable zone, the region around a star where temperatures allow liquid water to exist. They search for exoplanets within these zones, hoping to find signs of life beyond Earth. In an infinite universe, the question changes from if life exists elsewhere to how diverse that life might be. Every conceivable biochemistry, every possible evolutionary path, every imaginable form of consciousness would exist somewhere, repeated endlessly across the cosmic expanse. Consider the implications for evolution. On Earth, the path from simple cells to complex organisms unfolded over billions of years, shaped by countless environmental pressures and random mutations. This specific evolutionary history produced the remarkable biodiversity we see around us, from deep-sea creatures to soaring birds to self-aware primates. In an infinite universe, evolution would take every possible path. On some distant worlds, intelligence might emerge from ocean-dwelling cephalopods rather than land-dwelling mammals. On others, collective consciousness might develop instead of individual minds. Forms of perception and cognition beyond our imagination would arise, attuned to different sensory landscapes and environmental challenges. The anthropologist Mary Catherine Bateson once remarked that the true gift of human consciousness is the ability to imagine perspectives other than our own. An infinite universe realizes this gift on a cosmic scale, manifesting every possible form of being and awareness. This infinite diversity does not diminish the significance of life on Earth. Rather, it places our particular expression of life within an endless tapestry of possibility. We are both utterly unique in our specific configuration and utterly common in our inevitable recurrence. The philosophy of existentialism suggests that in a universe without inherent meaning, we create meaning through our choices and actions. An infinite universe extends this creative responsibility. If everything that can happen does happen somewhere, then meaning emerges not from uniqueness, but from the intensity and authenticity with which we experience our slice of infinity. The writer Jorge Luis Borges captured this paradox in his story, The Library of Babel, which describes an infinite library containing every possible book. Most volumes are nonsensical, random arrangements of letters. But somewhere in that infinite collection must exist every book that could ever be written, including perfectly accurate biographies of every person who will ever live. Borges' narrator describes both the despair and the exaltation of this infinity. The certainty that everything has been already written nullifies or makes phantoms of us all. But I also know that I, the imperfect librarian, am not a phantom. Similarly, in an infinite universe, we confront the paradox of being both infinitely repeated and irreplaceably present in this moment, this life, this specific node of cosmic awareness. For conscious beings like ourselves, this creates a strange kind of cosmic immortality. If infinite copies of you exist across space, then in some sense, you are eternal. When one version dies, countless others continue. Even after our sun expands and Earth is consumed, identical versions of you will still be experiencing this exact moment elsewhere in the infinite cosmos. This is not the personal immortality that many religions promise. These other yous are not continuous with your current consciousness. You would not experience their lives after your death, but it does suggest a pattern that never fully dissipates, an echo that never completely fades. The philosopher Alan Watts compared individual consciousness to a whirlpool in a flowing stream. The whirlpool has pattern and identity, but it is not separate from the water that flows through it. When the whirlpool dissipates, the pattern ends, but the water continues. In an infinite universe, the same pattern would form again and again, endless whirlpools of the same shape in distant parts of the cosmic stream. As you contemplate these ideas, notice how they shift your perspective on the life you are living now. Does the possibility of cosmic repetition make your choices seem less significant? Or more so, does the infinity of space make you feel small? Or does it connect you to something boundlessly vast? What happens to time when space has no end? Does infinity in space mean infinity in time as well? As we float through these cosmic questions, we encounter some of the most profound mysteries in modern physics. Imagine a river flowing endlessly. Does the river have a beginning? Will it ever reach an end? Or might it flow in a great circle, returning to its source? These questions about rivers mirror our questions about time in an infinite cosmos. In our daily experience, time appears to flow in one direction, from past to future. We remember yesterday but not tomorrow. We age forward, never backward. Eggs break, but do not spontaneously reassemble. This directionality, what physicists call the arrow of time, seems fundamental to our existence. But is this arrow universal and eternal? Will time itself continue forever in an infinite universe? The answers connect to the ultimate fate of the cosmos, what cosmologists call the eschatology of the universe. For much of human history, time was often conceived as cyclical. Ancient cultures across the world envisioned cosmic cycles of creation, destruction, and rebirth. The Hindu concept of kalpa imagines cosmic days and nights of Brahma, each lasting billions of years. Greek philosophers like Heraclitus proposed an eternally recurring cosmos of fire. These intuitions about cyclic time seemed natural in a world where seasons cycle, moons wax and wane, and generations succeed one another. Modern cosmology initially suggested a different story. When Einstein's theory of general relativity was applied to the universe as a whole, it predicted a cosmos that either expands forever or eventually recollapses in a big crunch, the reverse of the Big Bang. The fate of the universe, and of time itself, seemed to depend on the density of matter and energy. If the universe contains enough matter, gravity will eventually halt the cosmic expansion and pull everything back together. In this closed universe scenario, time might have both a beginning and an end, or perhaps the Big Crunch could lead to another Big Bang, creating a bouncing universe with cycles of time. If the universe has less than the critical density, it will expand forever, growing ever more sparse and cold. In this open universe scenario, time stretches forward infinitely, though the universe becomes increasingly inhospitable to life as stars burn out and matter disperses. A precisely balanced universe, exactly at the critical density, would expand forever, but at an ever-slowing rate. This flat universe would also suggest endless time, approaching absolute stillness as an asymptote. The discovery of dark energy in 1998 dramatically changed this picture. Astronomers found that the expansion of the universe is not slowing down, but accelerating. Some unknown force, which we now call dark energy, is pushing space apart faster and faster. In a universe dominated by dark energy, expansion accelerates eternally. Galaxies recede from each other at increasing speeds until they pass beyond each other's cosmic horizons, becoming permanently unobservable. Eventually, even molecules, atoms, and subatomic particles may be torn apart in what physicists call the Big Rip. Alternatively, if dark energy remains constant rather than increasing, the universe would expand forever but avoid the Big Rip. This scenario, called the Big Freeze or heat death, ends not with a dramatic tear, but with a fading whisper, as everything approaches thermal equilibrium. These scenarios suggest that even in an infinite universe, time might still have a beginning. The Big Bang remains the apparent starting point of our cosmic clock. But does time have an end? That depends on which cosmic fate awaits us. Something still unknown, despite our best measurements. Some theoretical physicists propose models that combine spatial infinity with temporal cycles. One such model, the conformal cyclic cosmology developed by Roger Penrose, suggests that the infinitely expanded state of one universe becomes the Big Bang of the next. In this view, time continues forever through successive aeons, even as each cycle appears to have a beginning and end from within. Other theorists explore the possibility that our universe emerged from a quantum fluctuation in a pre-existing space, a bubble in a greater cosmos. This could mean that while our time began with our Big Bang, there was time before time, existence before existence. These speculations remind us that infinity challenges not just our measurement, but our concepts. Infinity is not simply very big or very long. It fundamentally alters the logical landscape, creating possibilities that finite thinking struggles to encompass. Consider how infinity affects causality, the relationship between cause and effect that seems woven into the fabric of time. In a finite universe with a definite beginning, we can trace causal chains backward toward that initial moment. But in an infinite cosmos, especially one infinite in both space and time, causality becomes more complex. The philosopher Immanuel Kant identified this as an antinomy, a contradiction that reason cannot resolve. If every event must have a cause, then in an infinitely old universe, we face an infinite regression of causes stretching eternally backward. But if there was a first cause, a beginning of time, then what caused that first moment? Modern physics approaches this paradox through quantum mechanics, where causality becomes probabilistic rather than deterministic. At the quantum level, effects may not always have definite causes. Events can happen with only probabilities to explain them. This quantum fuzziness might resolve the infinite regression, suggesting a universe that begins not with a singular cause, but with a quantum probability. Even more mind-bending is how infinity affects entropy. the measure of disorder that gives time its arrow. The second law of thermodynamics states that in a closed system, entropy always increases. This law explains why heat flows from hot to cold, why eggs break but do not unbreak, why we remember the past but not the future. In a finite universe with endless time, entropy would eventually reach its maximum. All energy would dissipate, all structure would dissolve, all difference would vanish. This heat death would represent the end of time in any meaningful sense, a state where nothing happens because nothing can happen. But what about an infinite universe? If space truly has no bounds, then entropy can increase forever without ever reaching a maximum. New structures can continually form in distant regions, even as older regions decay. Time, in this scenario, continues eternally, not just as empty duration. This connects to a profound paradox first noted by the physicist Ludwig Boltzmann. If the universe is infinitely old, then it should already have reached maximum entropy, the state of heat death. Yet we observe a universe with structure, difference, and apparent youth. Why? One resolution suggests that our observable universe is just one fluctuation in a vastly larger cosmos. In an infinite and eternal universe, random fluctuations would occasionally create regions of low entropy. We exist in such a region, a cosmic oasis of order in a desert of chaos. Our time arrow points in the direction of increasing entropy, but elsewhere and elsewhen, other arrows may point differently. The philosopher of science Hugh Price compares this to watching waves on a beach. From our perspective, waves always move toward shore and then dissipate. But if we could observe the entire ocean, we would see waves forming and dissolving everywhere, with no overall direction. Our perception of time's arrow may be similarly local, a perspective limited by our position in the cosmic whole. These ideas suggest a profound reconceptualization of time in an infinite universe. Rather than a universal flow from past to future, time might be more like a vast landscape with different regions experiencing different histories. Some regions expand, others contract. Some evolve complexity, others dissolve into simplicity. Some sustain life, others remain sterile. In such a cosmos, our perception of time as a single flow becomes a local phenomenon, like weather in a planetary atmosphere. Just as rain falls in one place while sun shines in another, time might flow differently in different cosmic regions. This perspective finds expression in the block universe concept, a view of space-time as a single unified entity where past, present, and future all exist together. From this perspective, time does not flow. Rather, our consciousness moves through an already existing temporal dimension, like a reader moving through the pages of a book. The physicist Julian Barbour takes this even further, suggesting that time is not fundamental but emergent, a kind of illusion created by the relationship between different configurations of the universe. In his view, what exists are timeless moments, what he calls nows, and the appearance of flow comes from the connections between these moments. These theories may seem abstract, disconnected from lived experience, yet they touch something essential about our relationship with time. We experience time as both flow and stillness. We feel ourselves moving through moments, yet also being present within each moment. We perceive change, yet seek permanence. In an infinite universe, both aspects of time find their place. The flow continues eternally, yet each moment stands complete in itself. Nothing is lost to time, because time itself has no boundary. Every moment that exists forever as part of the cosmic whole. As you rest in the quiet of night, feel yourself suspended in this dual reality. You are moving through time, from moment to moment, breath to breath. Yet you are also still, present in a now that connects to all other nows across the vastness of space. What happens when probability meets infinity? What strange realities emerge when we stretch the fabric of existence without limit? In this chapter, we journey into the bizarre consequences of an infinite universe, where our intuitions falter and logic takes unexpected turns. Imagine flipping a coin. The odds are simple: 50% chance of heads, 50% chance of tails. Now imagine flipping that coin an infinite number of times. What patterns would emerge? Mathematics tells us something remarkable. Not only would you get roughly equal numbers of heads and tails, but every possible sequence would appear. 1,000 heads in a row. Perfect alternation between heads and tails for 1,000,000 flips. Any pattern you can name, no matter how improbable, would occur not just once, but infinitely many times. This thought experiment reveals a profound truth about infinity. In an infinite context, probability works differently. Events of any non-zero probability must occur, and not just once, but endlessly repeated across the infinite expanse. In our finite experience, probability guides our expectations. We know that rolling 10 sixes in a row on a fair die is possible, but extremely unlikely. Yet, in an infinite universe, this rare event happens an infinite number of times. In fact, it happens in an infinite number of places at this very moment. This insight leads to one of the strangest consequences of cosmic infinity. Probability loses its conventional meaning. When we say an event has a 1 in a billion chance of occurring, we expect it to be extraordinarily rare. But in an infinite universe, events with 1 in a billion odds happen billions of times. Events with 1 in a trillion odds happen trillions of times. No matter how small the probability, as long as it is not exactly zero, the event occurs infinitely often. Consider what this means for rare cosmic events. The spontaneous formation of a brain with all the neural patterns of a human consciousness, what philosophers call a Boltzmann brain, has a probability so vanishingly small that it should never happen in our observable universe. But in an infinite cosmos, these disembodied minds would form through random fluctuations, not just occasionally, but infinitely many times. This leads to a troubling paradox. If Boltzmann brains occur infinitely often throughout an infinite universe, there would be far more disembodied minds experiencing chaotic, hallucinatory existences than minds like ours, experiencing ordered reality within biological bodies. Statistically speaking, we should be far more likely to be Boltzmann brains than humans. The fact that we appear to be humans living in an ordered universe, some philosophers and physicists suggest this paradox might actually be evidence against an infinite universe. Others propose that our understanding of probability, entropy, or quantum fluctuations must be incomplete. The paradox remains unresolved, a reminder that infinity stretches not just space but our very logic. Another strange consequence emerges when we consider infinite observers. In a truly infinite universe, there would be an infinite number of conscious beings making observations about their surroundings. These infinite observers would record every possible observation compatible with the laws of physics. This creates a selection bias problem. How do we distinguish between typical and atypical observations when there are infinitely many of each? How do we develop a cosmic statistics when our sample size is infinite? The physicist Alan Guth, one of the developers of inflation theory, calls this the measure problem. In an infinite universe, we need a measure, a way of comparing infinite sets to determine which observations are typical. Without such a measure, cosmology struggles to make predictions about what we should expect to observe. Consider another strange implication. Infinite histories. In an endless cosmos, not only would there be other planets identical to Earth, but there would be planets where history unfolded almost like ours, but with slight variations. Planets where the dinosaurs never went extinct. Planets where Rome never fell. Planets where different people became historically significant. Every possible history consistent with the laws of physics would play out somewhere. Not as parallel timelines in the quantum sense, but as actual physical realities in distant regions of the same infinite space. Every path not taken in our history would be taken elsewhere. This multiplicity extends to future possibilities as well. Every potential future for humanity, from extinction to interstellar civilization, would happen somewhere in an infinite cosmos. Our timeline would be just one thread in an infinite tapestry of possibilities, all physically realized across endless space. These infinite variations create another paradox. In an infinite universe, with finite possible states, history must eventually repeat. After enough time and space, the exact configuration of matter that constitutes our present moment must recur. This is known as the Poincaré recurrence theorem, and it suggests that given enough time, any system will return arbitrarily close to its initial state. If the universe lasts forever and is truly infinite, then not only does history repeat, but it repeats infinitely many times. Our exact moment, with every atom in precisely the same position, with every thought in every mind identically recreated, would occur again and again throughout infinite space and time. The philosopher Friedrich Nietzsche called this eternal recurrence, though he conceived it in temporal rather than spatial terms. He considered it the heaviest burden. The thought that every pain, every mistake, every moment of suffering would return eternally, unavoidably. Yet he also saw it as a test. Could one affirm life so completely as to will its infinite repetition? In an infinite universe, this recurrence happens not because time circles back on itself, but because space extends without end, containing all possible configurations of matter, infinitely many times. The physics of infinity leads to other counterintuitive results. Consider vacuum energy, the background energy present in empty space due to quantum fluctuations. In quantum field theory, these fluctuations should contribute an enormous energy to every region of space. Calculations suggest the vacuum energy should be 10 circumflex, 120 times larger than what we observe, a discrepancy that physicist Leonard Susskind has called the worst theoretical prediction in the history of physics. One proposed solution involves the anthropic principle in an infinite multiverse. If different regions of an infinite cosmos have different vacuum energies, then life would only arise in the rare regions where the vacuum energy happens to be small enough to allow galaxy formation. We observe a small vacuum energy not because it's typical, but because it's necessary for our existence. This anthropic reasoning depends crucially on an infinite cosmos with varying physical parameters. Without infinity, the fine-tuning of our universe's constants becomes much harder to explain. Scale itself becomes paradoxical in an infinite universe. Consider Olbers' paradox, named after the 19th century astronomer Heinrich Olbers. If the universe is infinite, eternal, and uniformly filled with stars, then every line of sight should eventually end on a star, making the night sky blindingly bright. The fact that the night is dark seems to contradict an infinite universe. The resolution lies in the finite age of our observable universe. Light from the most distant regions hasn't had time to reach us. Additionally, the expansion of space redshifts distance starlight to invisible wavelengths, and stars have finite lifetimes. These factors explain the darkness of night without requiring a finite universe, allowing infinity to remain a possibility. The concept of infinity creates paradoxes even in purely mathematical contexts. Cantor's discovery of different sizes, or cardinalities of infinity, showed that even among infinite sets, some infinities are larger than others. The infinity of real numbers is larger than the infinity of integers, for instance. How does the human heart respond to infinity? What emotions arise when we truly contemplate endless space? This chapter explores not the mathematics or physics of the infinite, but something more intimate, the felt experience of existing within something that has no bounds. Close your eyes for a moment. Imagine yourself floating gently in space, far from any planet or star. In every direction stretches darkness, punctuated by countless points of light. Now imagine that these stars continue forever. No matter how far you travel, you will never reach an edge, a boundary, a final star, beyond which there is only emptiness. How does this vision make you feel? For many, the first response to cosmic infinity is a profound sense of awe. The philosopher Immanuel Kant identified two sources of awe: the moral law within and the starry sky above. Both, he suggested, fill the mind with ever new and increasing admiration and reverence. Awe arises when we encounter something so vast that our ordinary mental frameworks cannot contain it. Our minds stretch to accommodate the unaccommodatable. We experience what psychologists call cognitive accommodation, the mental equivalent of eyes adjusting to sudden darkness. Something in us expands to meet the immensity before us. Research suggests that experiences of awe often trigger a diminishment of self-importance, and an increased sense of connection to something larger. Time seems to slow or stop. Boundaries between self and world grow porous. Concerns that normally preoccupy us, from daily anxieties to long-term ambitions, temporarily recede before the vastness we contemplate. This transformative power of cosmic awe has been recognized across cultures and throughout history. The Romantic poets sought it in mountain vistas and stormy seas. Indigenous traditions found it in the rhythms of nature and cycles of the stars. Religious mystics described it as a glimpse of divine reality. Modern astronomers speak of similar feelings when discovering new cosmic wonders. Yet awe is not the only emotional response to infinity. Many also experience a profound sense of loneliness. If space continues forever, we seem impossibly small within it. Our entire civilization, even our galaxy, becomes a mere speck in an endless ocean. This cosmic loneliness can trigger what philosopher Pascal called the silence of infinite spaces, a vertigo of isolation. The writer Edgar Allan Poe captured this feeling in his prose poem Eureka. In the original unity of the first thing lies the secondary cause of all things, with the germ of their inevitable annihilation. For Poe, the infinity of space suggested not comfort, but inevitable dissolution. Each moment of consciousness merely a temporary pattern in cosmic flux. Others experience not loneliness, but its opposite, a deep sense of connection. If everything is part of the same infinite cosmos, then nothing is truly separate or isolated. The boundaries we perceive between self and other, between human and nature, between Earth and cosmos, reveal themselves as arbitrary divisions within a continuous whole. The astronomer Carl Sagan expressed this perspective when he noted that we are star stuff, contemplating star stuff. The atoms in our bodies were forged in stellar furnaces billions of years ago. The carbon, nitrogen, oxygen that make up our cells underwent a cosmic journey before becoming part of us. In this sense, we are not in the universe. We are of it, expressions of its patterns and processes. This connection extends beyond matter to consciousness itself. If mind emerges from physical complexity, and if an infinite universe contains infinite expressions of such complexity, then consciousness may be not an anomaly, but a natural feature of cosmic evolution, appearing wherever conditions allow, like crystallization in a saturated solution. The concept of infinity also evokes wonder, distinct from but related to awe. While awe overwhelms, wonder invites exploration. It asks questions rather than silencing them. It maintains a certain playfulness, even while confronting vastness. The cosmologist Lyman Spitzer described looking through a telescope as finding a diamond lying on the sidewalk. Each glimpse into cosmic depths reveals unexpected treasures, patterns unseen before, mysteries calling for investigation. An infinite universe offers endless opportunities for such discovery. Wonder has a particular relationship with time. It suspends our usual forward momentum, our rush from one task to the next. When we wonder, we linger, we attend. We allow ourselves to be drawn into the present moment, fully experiencing what is before us, rather than hurrying toward what comes next. In this way, wonder at the infinite creates a paradoxical experience of timelessness within time. The endless extension of space somehow folds back to intensify our experience of the here and now. Eternity touches the moment. Fear, too, arises when contemplating infinity. Not just fear of our smallness, but fear of meaninglessness. If everything continues forever, what significance can our brief lives have? If every possibility is realized somewhere in infinite space, do our choices lose their weight? The Danish philosopher Søren Kierkegaard described this as the dizziness of freedom, the vertigo that comes from recognizing the vast field of possibility in which we exist. Without fixed reference points, without absolutes to anchor us, we must create meaning rather than discover it. This freedom can be both exhilarating and terrifying. Yet many find that infinity does not empty meaning, but transforms it. Meaning shifts from cosmic significance to personal significance. What matters is not whether our lives change the fate of the universe, but whether they are lived with authenticity, connection, and purpose in our local context. The theoretical physicist Brian Greene suggests that the rarity of existence becomes its own kind of meaning. Even in an infinite universe where everything possible happens somewhere, each specific life, each particular consciousness, remains vanishingly rare compared to the vastness in which it occurs. Like a perfect snowflake, each conscious moment is both patterned and unique, both following natural laws and expressing them in ways never precisely duplicated. Humility emerges naturally from contemplating cosmic infinity, not humility as self-abasement, but as accurate self-perception. We see ourselves as neither central to cosmic purpose nor irrelevant to it. We are participants in an unfolding process that extends beyond our comprehension in all directions. This cosmic humility can be liberating. It frees us from the burden of cosmic specialness, the need to see ourselves as the pinnacle or purpose of creation. It places us within nature rather than above or separate from it. It connects us to all other conscious beings as fellow explorers of the infinite. At the same time, infinity can evoke a particular kind of courage. If the universe extends without limit, then no finite failure is final. No local disaster is cosmic in scale. Even extinction would affect only one branch of life's possibility, leaving infinite others to continue across endless space. This is not to diminish the real suffering and loss that occurs within our finite experience. Pain remains pain. Grief remains grief, regardless of cosmic context. But infinity offers a perspective from which to view these experiences, a context that neither erases nor defines them. Perhaps the most complex emotional response to infinity is love, not in the romantic sense, but as a quality of attention and care. To love the infinite is to love that which can never be fully known or possessed. It is to love mystery itself, the endless unfolding of reality beyond our conceptual horizons. As our journey through the concept of infinity comes to a close, we find ourselves not at an end, but at a pause. A quiet moment to reflect on where we've been and what we've discovered about this largest of all possible ideas. We began by asking what it means to be inside something that never ends. We explored the geometry of infinity, the evidence for an endless cosmos, the strange consequences for life and consciousness, the nature of time in boundless space, the paradoxes that emerge when probability meets eternity, and the deeply human emotions that arise when we contemplate the infinite. Throughout this journey, we have moved between certainty and uncertainty, between what we know and what we can only imagine. The question of whether our universe is truly infinite remains open. Our observations suggest a flat geometry consistent with infinite space, but we can directly observe only a finite region, our cosmic horizon limited by the age of the universe and the speed of light. Perhaps someday we will know for certain. Perhaps future measurements will detect a subtle curvature in space, suggesting a finite cosmos. Perhaps new theories will resolve the paradoxes of infinity. Or perhaps infinity will remain forever at the edge of our understanding, an idea we can approach but never fully grasp. But even without certainty about the physical infinity of our universe, the concept of infinity continues to expand our minds and hearts. It reminds us that beyond every boundary lies more to discover. Beyond every answer lie deeper questions. Beyond every horizon extends further space. Whether the universe is infinite or not, we live as if it is. Each day, we awaken to new possibilities. Each question we answer leads to further inquiry. Each discovery opens doors to unexplored territories of knowledge and experience. The human journey, like the cosmos itself, continues without apparent end. This endless quality of experience connects us to infinity regardless of cosmic geometry. When we look at a night sky filled with stars, when we contemplate the branching paths of possibility, when we experience love that seems boundless, we touch something of infinity within our finite lives. The mathematician Georg Cantor, who revolutionized our understanding of infinity, wrote, "The essence of mathematics lies in its freedom. Perhaps the essence of infinity lies in a similar freedom, the release from boundaries that constrain not just space but thought itself. Infinity invites us to think beyond limitations, to imagine beyond horizons, to love beyond boundaries. It challenges us to hold opposites in creative tension, the vast and the tiny, the eternal and the momentary, the universal and the particular. In an infinite universe, or even in the contemplation of one, we discover our unique position. We are neither the center of everything, nor nothing at all. We are participants in an ongoing cosmic story, conscious nodes in a vast network of matter and energy, meaning makers in a reality that both transcends and includes us. Every moment, every thought, every breath becomes part of something far bigger, not lost in vastness, but connected through it, not diminished by endlessness, but given context within it, not rendered meaningless by infinity, but granted the freedom to create meaning, precisely because no cosmic boundary imposes it from outside. The philosopher Alan Watts compared human consciousness to a whirlpool in a flowing river. The whirlpool has form and identity, yet it is not separate from the water flowing through it. It exists as a pattern within a larger movement. In this metaphor, we are whirlpools in the infinite river of cosmic energy, distinct but not separate, individual but not isolated. As you drift towards sleep beneath an endless sky, remember that you are not an alien in this cosmos. You are not a stranger lost in infinite space. You are a natural expression of cosmic processes, a way that the universe experiences itself, a consciousness that brings infinity into awareness. The atoms in your body were forged in ancient stars. The energy that powers your thoughts flows through the entire cosmos. The laws that govern your biology operate throughout space and time. You are, in the deepest sense, at home in this universe, infinite or not. This belonging does not answer all questions or solve all problems. It does not tell us the correct path forward for humanity or guarantee our survival as a species. It does not erase suffering or eliminate uncertainty. But it does provide a context, a cosmic background against which our brief, brilliant lives unfold. Infinity is not a destination, it is a direction. It is the slow turning of galaxies that never stop, the light from stars that never fade, the space between moments that never closes. It is the openness at the heart of reality, the endless becoming that characterizes existence. As night deepens and consciousness loosens its hold, as thoughts dissolve into dreams and dreams into sleep, know that you rest within this infinite turning. Your awareness may fade, but the cosmos continues its dance. Stars burn, galaxies wheel, space expands, time flows. And when you awaken, it will all still be here, waiting for you to rejoin the cosmic conversation. Sleep now, beneath an endless sky. You are not lost in infinity. You are part of it. Your consciousness is one of the ways the universe knows itself. Your questions are cosmic curiosity expressed through human form. Your wonder is the cosmos wondering about itself. Whether space extends forever or curves back upon itself, whether time continues endlessly or eventually concludes, whether consciousness is rare or common throughout the cosmos, you exist now as a witness to the great mystery of being. This witnessing, this participation in conscious experience, connects you to something without end. In the quiet darkness, as breath slows and thought stills, feel this connection, not as an idea, but as a lived reality, not as a concept, but as an experience. You are held in the gentle palm of a cosmos that cradles galaxies. You are breathed by the same processes that inflate nebulae and collapse stars. You are thought by the same reality that dreams up quarks and quasars. Rest in this belonging. Sleep in this embrace. Dream within this larger dreaming, and know that infinity continues its quiet turning all around you, within you, through you, not as something distant to be feared, but as something intimate to be recognized. Not as emptiness that diminishes meaning, but as openness that allows meaning to emerge. Not as coldness that numbs the heart, but as space that gives the heart room to expand without limit. This is infinity, not a conclusion, but an ongoing question. Not an answer, but a journey. Not a destination, but a direction. Always moving, always turning, always opening into further possibility. And you are not separate from this movement. You are integral to it, essential to it, a unique expression of its endless creativity. a particular note in its infinite symphony. Sleep now, dreamer of the infinite. Rest in the arms of endless space. You are home. You have always been home. You will always be home. In infinity's gentle turning, you have your place, your time, your being, never lost, never alone, never ended, always becoming.